Okay, this is the first video on completing the square, other than the overview. The goal here is going to be to change some equations like this to standard form. Okay, so in each one of them for this video, the x squared term is always just going to be 1x squared, because it's a bit easier like that. And so, just a reminder that completing the square essentially means writing in standard form. So it'll be writing this as like x plus something squared plus something else. Okay. So first of all, we're just going to take a look at some number patterns here. So I've written a bunch of perfect squares because we're going to want to go backwards. We're going to want to write this as something x plus something squared. So we'll just look at what the numbers look like so we can figure out how to do that. So x plus 3 squared, I just wrote a few examples here, is x plus 3 times x plus 3. And that, if we multiply that out, we get x squared plus 3x plus 3x plus 9. 3x, 3x, and 9. And then I'll just group my x terms. So I have x squared plus 6x plus 9. Okay, I'll do a few more. X minus 5 squared. That's x minus 5 times x minus 5. That's x squared minus 5x minus 5x plus 25. Careful, remember it's plus 25. Negative times negative. And then that's x squared, I'll group these, minus 10x plus 25. Okay, next one, I just want to have a few so I can look for some patterns. X plus 1, feel free to pause it and do it yourself and then check the answers after. Just can fast forward me to check. So it's x plus 1 times x plus 1, and we get x squared plus 1x plus 1x plus 1, and of course that's x squared plus 2x plus 1. Here I have 2.5. So x squared plus minus, 2.5, oh my dear, I skipped ahead a little bit, times x minus 2.5. And that gives us, here's the x squared, and then minus 2.5x minus 2.5x minus 2.5x. And negative 2.5 times negative 2.5 is plus 6.25. So that's equal to x squared, and then here, negative 2.5 minus 2.5 is minus 5x plus 6.25. Okay, so now we've got a few examples here. We want some patterns. So we're kind of looking at the relationship between these numbers and these numbers. Okay. The first thing I want you to notice is that when we have the simplified version, like the version that looks like general form, the number of x's we have here is double that number. And this totally makes sense, because when we expanded it, well, how did we get it? Well, we got it from 3x here plus another 3x. Right, there's two of them. That's why it's double. It's nothing special. This negative 10 is 2 times negative 5. Plus 2, that's double, plus 1. And the negative 5, that's double the negative 2.5. So if we look down at these questions, this is the direction I'd like you to go in. It feels a little bit abstract at the start. Okay. We have x squared plus 8x. And I want that plus something. We'll fill that in a sec. I want to know, well, that's x plus what squared? Well, this x squared plus 2x, that was 1. Here we had negative 5, that's negative 2.5. So this number that's in the perfect square is going to be half of the 8. So it's going to be 4. Okay. And then what is this going to be here? Well, x plus 4 squared, what would that be equal to? If we imagine x plus 4 squared, we come out with x squared, and then 2 times that, because of the two terms. So it would be 8x, so that's what we want. And then what's the last term? Well, the last term in all these, here we have plus 3, x plus 3 squared. And the last term is where we do 3 times 3 is 9. And here, negative 5. Well, negative 5 times negative 5 is plus 25. The last term is always just the square of this guy. So this is going to be plus 16. Okay? And then just to check, just to make sure that, like for the first little while, you'll want to check that. Just to make sure you didn't get anything mixed up. That's x squared plus 4x plus 4x plus 16. And that's x squared plus 8x plus 16. Perfect. That's perfect. Okay. So here, with the next one, x squared minus 12x plus something. So this can be whatever I want, and I want it to come out to be a perfect square here. So, well, what is the relationship here? Remember this is twice as much as this number. So if I've got minus 12x, I'm going to have minus 6 here. And watch that the sign is the same as the sign there. So it's negative 12, and divide by 2, and it's negative 6. And then what's this term going to be? To make this a perfect square, well, it's going to be that squared. So negative 6 times negative 6 is 36. Okay. And so if that 36 seems strange to you, then just stop and pause it, ignore what I wrote there, and just square this. That's what I'm going to do in a second, and we'll see that the 36 comes up. So what we do, I'll do is check x minus 6 squared is x minus 6 times x minus 6. That's x squared minus 6x minus 6x. That's why it's double over here, because there's 2 of them. And then negative 6 times negative 6 is 36. So x squared minus 12x plus 36. Which is just what we thought. Okay. And then the last one, x squared plus 3x. So I want to figure out what this term should be. It's going to be in my perfect square. So this is going to be twice what this number is. So to get this number, again, just like I did up here and here, I'll divide it by 2. So it's going to be plus 1.5. And then to get this number, I square that. So 1.5 times 1.5, I should have put that in pink, plus 1.5, and then 1.5 squared is 2.25, 2 1/4. Okay. And then we can check that one too. I'll leave that to you to check. If you're not sure, just multiply this one out. You should get that. Okay, so your job, you're going to have to be able to look at something like x squared plus 3x, and say what could we add to that to make it a perfect square. So what you're going to do is divide, and I'll call this the b term because we've always been called that b term. Divide b by 2, and then square it. That's what we did here. We had 8 to get this number. If you wanted to do that in one step, you do 8 divided by 2 was the 4, and then square it to get 16. And if we look at these, we know these are perfect squares, because that's where they came from a perfect square. We've simplified it. And let's check and make sure it always works. Negative 10 divided by 2 is negative 5, squared is 25. 6 divided by 2 is 3, 3 squared is 9. 2 divided by 2 is 1, 1 squared is 1. 5 divided by 2 is negative 2.5, and negative 2.5 squared is 6.25. Okay. So that's going to be the pattern when we're looking for this constant term here. We're going to divide that by 2 and then square it. So I'm going to do 3 examples here where we complete the square on these terms, on these expressions. And essentially what that means is we're changing it, we're writing it in standard form. Okay? Kind of the same thing. Just type this down. Okay. So, y equals. The first step is actually going to feel like you're going to do nothing. But I'd like you to do it because once we start working with a values that other than 1, so maybe if you had 5x squared here or something like that, the next step is really important. But first, so now I'd just like you to do, it's super easy, just put the first 2 terms in brackets. So we didn't really do anything yet. Okay, we've got x squared plus 6x plus 5. So that's essentially nothing. It sort of helps us visually like divide this part off too. What we're going to try to do here is take this and turn that into a perfect square. Okay? So we'd have x squared plus 6x. And the question is x squared plus 6x plus what will be a perfect square? And we've seen with the numbers that what we do is we divide it by 2 and then we square it. So we take this 6, just the coefficient, divide by 2 to get 3, and square it to get 9. So I'm going to add 9, because that will be a perfect square. The thing is, I can't just go about like adding 9 to my equations, because it'll totally change them. But I really would like to add 9. So I'm going to do this little trick here, where I add 9, and then, so to avoid like totally changing the value, I'll put minus 9 there. Because plus 9 minus 9, I haven't changed anything there, that's like I didn't do it. Plus 5. Okay, so we're just sort of reorganizing here. What I'm going to do now is I'm going to regroup. We've got x squared plus 6x, or not even really regroup. I'm going to take this negative 9 out of the brackets so we can kind of see what's going on. We've got plus 9 here, and then I'll put minus 9 plus 5. Okay. So right now it looks like these brackets are sort of almost decorative. If we have another, like a coefficient on the x squared term, they'll be really important. But right now they're sort of just visual. So here's the trick. This is where all the magic comes in. So x squared plus 3x plus 9, sorry, x squared plus 6x plus 9, that's a perfect square. Okay? And from those patterns we saw earlier, we should be able to recognize which perfect square it is. And in fact, I think, it was one of the examples we did. X squared plus 6x plus 9, that's x plus 3 squared. And this is always going to end up being, if we've done it right, it'll always be a perfect square, because we chose the numbers that would make it a perfect square. Okay? So it's x plus 3 squared. Okay? And the way we find that, if you hadn't say just done it, is we take this number and divide it by 2. Right? That's the pattern. Here, when we're doing these ones, we took our 8 divided by 2 to get 4. Here we took negative 12 divided by 2 to get negative 6. Okay. So this is x plus 3 squared. That was the magic part. And then here we just have minus 9 plus 5 is going to be minus 4. Okay? So that's the goal. And so it's just a little bit of sort of algebraic magic. Not really magic, obviously, every step makes sense. But it's just a little trick to be able to write this as in standard form. That will help us if we wanted to do something like find the vertex of this. We'd know it was negative 3, negative 4. And it will also help us solve the equation. If this was equal to 0, we'd be able to solve it. Okay? So, as you do these, you can double check your work by graphing the given question in y1, and then the last one in y2. They should be exactly the same. Okay, I'll do 2 more examples here. I'm going to do them a bit quicker, so feel free to just pause and think about anything when you want, about things when you want to. I just don't want to make the video run too long, because it slows down the uploads and downloads. Okay, but pause it whenever you need to. Okay. Here, I'll just put these first two terms in brackets. It just kind of helps me visually see what I'm working with there. Now I've got x squared minus 8x. I would like to make that into a perfect square. So what I'm going to add to it to do that, to get what I add, I take the 8, negative 8, divide by 2. Negative 4, let me write this down. Negative 8 divided by 2 is negative 4, and then negative 4 squared is 16. So I'll add 16. And then I can't just go around adding 16, so I have to subtract 16. And then I've still got this plus 2. Okay. And now, because I want to sort of keep my perfect square looking separate here, so I'm going to take this minus 16 and I'll just bring that outside the brackets. There we go. And then here's the big step here. My x squared minus 8x plus 16, that is a perfect square. And to figure out what goes here, we take this number, the negative 8, and divide by 2. So it's going to be x minus 4 squared. And then here we've got, at the end we've got negative 16 plus 2 is negative 14. And then say you just wanted to double check. You could always just sort of off to the side do x minus 4 squared. That's x squared minus 4x minus another 4x plus 16. So that is exactly what we had, so that makes sense. Okay, and then one last one here. We've got y equals, and I'll just pop these first two terms in brackets. Okay. And then I'm going to do this magic adding and subtracting here, this sort of strange number that we pull out of nowhere, because we're trying to just engineer this to be a perfect square. So how do I find that number? I take my 9, I divide it by 2, I get 4.5, and then I do 4.5 squared. Okay. What is 4.5 squared? Pop that in your calculators. 25. There we go, plus it's 20.25. This is 20.25. So that's going to be sort of my magical number here. Sorry, it's a bit hokey to always be calling this magic. But this sort of special number that it seems out of the blue. It seems like I'm adding and subtracting out of the blue. This is how I get it. So I'll add 20.25. And then I'll subtract 20.25. And then I've got minus 1. I'm writing on top of things. Okay. So that's that special business there. And now I'll just pull this second one out of the brackets, just so we can see what we've got for a perfect square. Okay. And then here, there's our perfect square. So what is it? Again, we take our 9, divide by 2, and we get 4.5. And then out here we've got minus 21.25. If you wanted to check, you could just go over here and take x plus 4.5 squared, and you come out with x squared plus 9x plus 2.25. Okay. So, you ready to move on to the next video when you can do the following? So you understand it and you're good enough, you have practiced it enough that you can do it well if you can complete the square on 5 quadratics like these, with all of them correct, that's the most important part, and that you can do it in less than 10 minutes. If it's 10.5 minutes, that's close enough. But if it takes you 20 minutes, then you're too slow and you just need to practice more so that you're really, really comfortable with it. So here's an example of 5, here's another 5. You can make up 5 other ones. There are just some things I want to point out. I have a variety of pluses and minuses, so positives and negatives. And that I think I put in most of them I put sort of 3 like even numbers, so that when you divide by 2 and square it, you get a nice whole number. And then a couple with odd numbers, so that you'll have a little bit of, just some fractions or decimals to deal with. So if you can do 5 like that, you can make them up yourself, or you can use these ones. If you can do them in 10 minutes or less and you get them all right, then you're good to move on to the next video. So how do you know if you get them right? You check your answers by graphing them. So you put the given ones, the ones I give you, in y1, and your answer in y2. And if it looks like the same parabola, you did it right. And if you've got 2 different parabolas going on, then you've got a mistake somewhere. Alright, good luck.